O is the center of the circle. KOM bisects chord LN, and angle MNO equals 26 degrees. K and P are points on the circle with K with NKP equals 32 degrees and OP is drawn. Okay, the diagram is very clear below. We proceed now to look at the questions at the bottom. Right, so if O is the center of the circle, we need to find, giving reasons, the size of the angle O2. Right, so we're going to look at the solution to 8.1.1, part A. Right, what is angle O2? Well, angle O2 is very, very interesting. We proceed to find the angle O2. Right, so we see that clearly angle O2 is actually equal to twice angle K1, which is then twice 32 degrees, which is 64 degrees. Angle at center, 2 times angle at circumference. Right, the next thing is we look at 8.1.1, part B, and we want to find the value of the angle O1. So first things first, we note that angle M2 is equal to 90 degrees. The reason is that it is true that you have, if you have a line from center to midpoint, the midpoint of chord. And therefore, we realize that the angle M2 is 90 degrees. From which we therefore see that KON, angle KON is therefore equal to 90 degrees plus 26 degrees. So in other words, we're able to see that angle KON is equal to that. So this is the same here. And the reason for 90 plus 26 is because the exterior angle of triangle. So this one here is 100 and what? 116 degrees. Right, and therefore to find the angle O1, we can see that angle O1 is therefore the same as 116 degrees, because you can see that KON here is 116 degrees, which means angle O1 is 116 minus 64 degrees. Because we know that angle O2 here is actually 64 degrees. So 116 minus 64 degrees. And 116 minus 64 degrees is equal to what? Is equal to 52 degrees. So the implication is that angle O2 is 64 degrees. And we can see therefore that angle, right, you can see that angle O2 is 64 degrees. Angle O1 is 52 degrees. Right. We now look at 8.1.2. Proof giving reasons that Kn bisects angle Okay, so now you have K here, you have N here. You need to prove that it bisects angle OKP. So you have O, you have K, is P. So you have that this here is bisected, or rather bisects that angle there. How do we proceed to prove this one? Right, so to prove this one here, we need to first realize that angle PKO plus angle P is 128 degrees. Let's look at the diagram. Right, we can see that angle PKO. So if you have PKO, you can see that it is, when added with angle P, which is this one here, is 128 degrees. I mean, we know that this one here, O1, is 52 degrees. So the sum of the other two angles in the triangle, so this is the sum of angles in triangle. So PKO is P. Okay, all right. So if PKO is P, why is PKO, this one here, equal to angle P? Well, because we're dealing with radii here. Right, so we therefore have the angles opposite equal sides. Angles opposite equal sides. Okay, angles opposite equal sides. And we proceed. Right, we proceed. Angle opposite equal sides, and we proceed. So now this is the same error 64 degrees. Yes, it's 64 degrees because it's 2 times this one is 64. In other words, here you have 64 degrees. But also this other angle here is 64 degrees. Which means therefore K2 is equal to 32 degrees. Or you can say, so it means therefore K2 is 32 degrees because this angle here is also 32 degrees. Angle K1 is also 32 degrees. Okay, this has become so untidy when we clean it up a little bit. But you can see clearly what's happening here. Okay, so as a consequence, what we're getting, that K2 is 32 degrees, or K1, angle K1 is equal to angle K2. And now when K1 is equal to angle K2, so we have that this one here is equal to that angle there. And then this here is the conclusion. We can draw that angle, therefore Kn bisects. Bisects OKP. And therefore we are done. All right, so thanks everybody for participating. So we're done and we've proven this, and goodbye.